And once again, thank you for joining us on day one of TIA's Network of the Future conference right here in Dallas, Texas. Joining us in the Dell TIA Now studio is Steve Riley. He's the Deputy CTO at Riverbed Technology. And Steve, welcome to the program.
Thanks, it's good to be here.
Thanks for being here. Prior to this filming, I had a chance to check out your resume. You've clearly been in the business for quite some time. You've worked for some real powerhouses in the industry. I can imagine the breadth of knowledge you could bring to a conference like this, but also to our studio here at TIA Now, so we appreciate your time.
Sure, thanks for inviting me.
Thank you very much. Now, we had, in all honesty, a number of questions to ask you. We had a chance in our pre-show discussion to talk about making some changes to those questions, and for a good reason. The reason is this, is to talk about how to bring data to the consumer instead of making data available based on the network capability and some geolocation. Can you explain that to us?
Right. One of the interesting things that we've been thinking about at Riverbed is this notion of location independence. How can we make location not be a constraint anymore when people think about where to place workloads, where to place storage, where to place users, and do we have to make a decision about the distance or how long it takes for data to get from one place to another? If we can eliminate that as a deciding factor, as a constraint, then I think it opens up a lot of new opportunities for people to do new things with IT and their data that they haven't done before.
Now, if my internet speed slows down, it's not just the speed of my connectivity within that one location, right? The network conditions could have changed while I was watching that particular piece of content. Is that right?
Yeah, there's all kinds of things in the way between you and your YouTube channel that you might be watching, or if you're thinking about a business workload, if you've moved your email, for example, from on-premise to Microsoft Office 365, there's distance involved there that hadn't existed before when your data center was right in the building next to you, for example. One of the common approaches that people think to fixing this problem is, well, let's just throw bandwidth at it. Let's make the pipes fatter, because faster bandwidth means faster bits, right? Well, that's true to a certain degree. Adding more bandwidth is going to give you a better user experience. But there's this interesting phenomenon called the speed of light. Electrons and photons have an upper bound in how fast they will go. So more bandwidth doesn't necessarily translate into a better user experience for chatty applications. If there's lots of data that goes back and forth, you need to address the latency side of that too, the time it takes for that to happen. And so much of what we concentrate on at Riverbed is those other aspects of performance. How can we make the problems of latency disappear? How can we make it feel like it's still next door, even though it might be on the other side of the planet?
Is there a perception, Steve, by the industry that when you move your data to the cloud, to virtual data centers, virtual cloud services, that your performance will be less robust and less, well, I guess robust. Is that perception reality, or is that true?
It is a perception, and it is also true. We have talked with a number of customers about moving to the cloud and how it makes the experience feel different. It takes longer for a mailbox to open. It takes longer for this mission-critical workload to complete its job, because some of the workload components might be far apart, whereas they used to be close together. And we have thought about how can we adapt the traditional branch office data center optimization that we've gotten really good at to these third-party services, to clouds like Salesforce or to Office 365. So when you think about innovating in new areas where the world is moving toward, we think it's important that we address what the future is going to be. And the future is distance, it's clouds, it's big data centers far away from where people are. And so we adopt the mechanisms and the technologies and the delivery vehicles that we've used to ensure consistent end user experience, regardless of what the deployment might be. Branch office data center today, cloud tomorrow.
Of course, in our pre-show discussion, we also talked about disaster recovery. Some methods of disaster recovery work and some don't. Some appear to work and some don't. Can you give us a use case, a real life example of a disaster recovery method that does work?
It's interesting, when people think about preparing for disaster recovery, they're usually concerned about making sure that there are copies of the data someplace else that can be retrieved quickly, or constructing a standby facility that looks exactly like or almost like the normal facility, and you can do a hot switchover or something like that. If you only replicate the data, what are you going to do when there's a disaster and you don't have any compute resources available? Not very useful, right? If you have a hot standby facility, you're paying for something that you're never going to be using, well, maybe rarely using. You hope never, but rarely going to be using. Perhaps there's a third way. And it turns out there's a very interesting third way. If you could package up all of the data that you have and all of the, say, the virtual machine descriptions that are used for the workloads that the machines that the data runs on, right? And ship that off to the cloud, say Microsoft Azure or Rackspace or Amazon Web Services. It doesn't really matter. You pick the cloud that you want. You're making a copy of the infrastructure in software and the data and then sticking it in an archive mechanism. So as long as you keep that replication going on a day-to-day basis, you're fine. Now a disaster strikes, right? Something happens, a meteor hits your data center, who knows what it could be. Since you've already got virtual machine descriptions and you've got policies and you've got copies of all of the data sitting right there in that cloud, you can reconstitute an on-demand copy of your data center, point your DNS server over to this one temporarily, and there you go. Now you're back in business. Employees can get access to their data. You're generating revenue again if you have services that are actually taking orders from customers, and you're back in business in maybe as short as 30 minutes.
We also talked again in our pre-show discussion about performance problems, and you said it's about the sequence of, and again, the methodology
right.
to tackling those performance problems. Can you give us a use case of that as well, or an example?
Well, the sequence is what really matters. People could guess at what they think the problem might be, and sometimes guesses are right, and sometimes guesses aren't right. But if you follow a process, then you're applying the technology correctly. So for looking at where performance problems might exist, we think that the first thing to do is analyze. Understand what's in your environment. What applications do you have? What are the dependencies that exist? Look for tight coupling versus loose coupling and understand where things need to be. Can they be far apart? Do they have to be close together? The analysis is the first step. The second step then is to diagnose where problems might be. If someone calls and says, hey, the network is performing badly, is it really the network? Maybe it's a transaction problem. Perhaps the database server is being overloaded and it can't handle all of the requests that are coming in. Or something has changed in the basic network performance baseline. If you've got data from analysis, the diagnosis then helps you understand where those deviations might happen to be at any point in time. After you've diagnosed those, then you can look at mechanisms for resolving that. How do you resolve performance problems? Do you need to use perhaps an application delivery controller that gets data closer to their users as they move around the planet in a follow the sun model, for example? Or is it appropriate perhaps to apply something like WAN optimization or a web content optimization to modify the content in such a way that it responds more quickly to users, but still making sure that integrity matters too. We don't actually want to change the data itself, but just change the way the data might be delivered to ensure that consistent, high quality, local feeling end user experience.
Steve, my impression when I first saw you in the dining room is that our segment would be interesting, and in fact it was. I don't know if it was your hair or what that got me thinking that way, but we appreciate your time again.
Thanks very much. It's good to be here.
All right, Steve. Thanks for joining our coverage of TIA's Network of the Future conference, the Dell TI Now studio. As always, we'll be streaming live throughout the conference. You can view our live stream and all of our programming at tianow.org. So long.